the first page, which I forgot to do. So this is problems 1 and 2. So the problems that I've been saying are 1 and 2 on the previous video are incorrect. So we're going to do number 1. So here's a table of numbers. We're supposed to find the average velocity. So between 0.25 and 1.25 or 1.5. So we got to take the position at the end, 14.13, minus position at the beginning, 6.55, over the change in time, which is 1.50 minus 0.25. So we have, so I don't make a mistake here, I'm going to just do it on my calculator. 14.13 minus 6.55. Then I can divide that by 1.5 minus a quarter is 1.25, and I get 6.064, and this would be meters velocity per second. Determine the central difference at 1.5, so I want to do 19.58 minus 10.36, either side of 1.5, over 1.75 minus 1.25. So 19.58 minus 10.36, and the difference there is 0.5 divided by 0.5, and I get 18.44 meters per second. Now I want to use a linear approximation to figure it out at 1.47, which means I'm going to write the equation for the tangent line at 1.5, which is close to 1.47. So that would be at a equal 1.5. And so the slope at 1.5 was 18.44 times x minus 1.5 plus the y value at 1.5, which was 14.13. And now we're going to use this to find at 1.47. So 18.44 times parenthesis 1.47 minus 1.5 close parenthesis plus 14.13, and we get 13.5758 rounded off, and this is to approximate s, which is the distance, which would be meters. Okay, if this is the derivative and its value is -3, f has to have a slope of -3 and getting to a slope of 0 by -1. -3, so I'll just start at the top. -3 is about this, about this steep, going and down to a slope of 0 by -1. So it gradually gets less steep and less steep, and then it gradually gets steeper in the positive slope up to a slope of 3. And this is where it should be flat, and then it goes to a positive slope of 3 by 9. So I probably shouldn't have started it so high. But this has to go up about 3 for 1 here and something like that. All right, the second derivative is just the slope of this graph, which is close to 0. and then it gets to a positive, oh, a little less than 1, but close to 1 here. So it gradually increases, and then it decreases back towards 0. And that's it.